Good morning, sir.
Good morning.
Could you please introduce yourself to the jury, stating your last name, spelling your last name for the court?
Good morning. My name is Robert Gilman, Gilman.
And what is your occupation, Mr. Gilman?
Meteorologist,
And where did you go to school?
Northeastern University and the Pennsylvania State University, Penn State.
And what degrees did you receive from those institutions?
I received a Bachelor of Science in Earth Science and in Meteorology.
Now, following your education, where did you first go to work?
I worked at the U.S. Geological Survey while I was finishing my education. I also worked at the Nuclear Regulatory Commission in Washington. I worked at AccuWeather at Penn State. And then I started my own business when I came back to the Boston area, working both in media, writing a column for the Patriot Ledger, radio, 95.9 WATD, and also providing information to municipalities about snow and ice in consulting.
Now, starting first with the U.S. Nuclear Regulatory Commission, what did you do there?
I worked in the Division of Site Safety and Earthquake Analysis. That was primarily involving siting nuclear power plants.
And as far as AccuWeather, Inc., what was it that you did there?
Meteorology. I worked starting out drawing maps. We drew our own maps back in those days, providing observations to meteorologists and helping develop forecasts.
Now, you had worked, you had mentioned earlier in your testimony, you'd worked as a meteorologist in New York for the radio, for the Patriot Ledger, and New England Weather Service. Is that correct?
New England Weather Science, that's correct.
And how long a period of time span are we talking about as far as your work as a meteorologist?
Over 45 years.
Now, if you could explain to the jury just in general terms, what is meteorology?
Well, the term is actually a shortened term of hydrometeorology, one who studies falling water things. And it's a study of the atmosphere.
Now, in your work as a meteorologist, what are the different types of data that you study and examine?
Mostly measured data such as temperature, humidity, wind, precipitation, but also sensing data with satellites that orbit the Earth and with radar that shoots electronic beams out and comes back and forms images that we can analyze.
Now, beyond the satellites and the radar, where does that other data come from?
Well, the observing stations generally are at airports, for instance, but they're also at utilities, and there are private networks. And these, either automated or amateur weather observers, take down data such as I just mentioned, temperature, precipitation, visibility at these different locations.
And what is your current occupation?
Meteorologist.
And where is it that you currently work?
I work for Precision Weather Forecasting Incorporated, and I also do work to assist requests for past weather data, both for clients of ours at Precision Weather Forecasting and other requests for weather data.
And is that a company that you started yourself in conjunction with other people?
Yes, thank you. It's a company that we founded. My partner and I've been working with meteorologist Bill Guile for 30 years. We're both local, and we found that we had a lot of interest together. I don't stay up 24/7. He stays up overnight a lot of times, and we work much better, on that shift kind of work during the day, answering questions of clients about snow and ice especially. So we formed our own corporation, a Massachusetts corporation, in 2016.
And how long, even prior to the incorporation in 2016, how long have you been working in that capacity for building that company?
Oh, I would say over 45 years, going back to 1979, 1980.
And what type of service does your company provide to your clients?
Precise snow and ice information. I own the website snowandice.com, and our clients depend on very local, precise snow and ice guidance. It's for safety, it's for efficiency, environmental concerns of not putting down a lot of chemicals when snow is going to change to rain, that kind of thing. So we're giving very local, precise weather information to help anyone that has snow and ice management concerns.
And if you could expound upon that just a little, sir, as far as what types of data or information is it that your company provides?
Mainly precipitation timing, when snowfall might begin in a particular place, the intensity of the snow, whether it might be expected to change to ice or rain or go back to snow or ice to help with those kinds of operations.
And where does that data or information come from?
As meteorologists, we develop it ourselves. It's all in-house. We take a variety of different data from numerical modeling, guidance products, and observational information and develop the forecast specifically for the client.
And as far as your clientele is concerned, to whom are you providing this data or information?
We work for most of the towns and the city in Norfolk County. We work for the largest cities in Massachusetts, some of the largest colleges and universities and other facilities, hospitals.
And what is the purpose of you providing that information to the clientele to whom you give it to?
Again, safety, efficiency, environmental concerns, to give them the best information to do the job they need to do. And it's a difficult job, as you can imagine.
Now, at some point, sir, were you asked to look at some data related to the Canton, Massachusetts area in the time frame leading up to and including January 29th, 2022?
Yes.
And what were you asked to do?
I was asked to provide a simple report of the days preceding January 29th, 2022, and a more detailed report of the early morning hours of January 29th about estimating snowfall during that time period.
And in total, as far as that total time frame, do you recall what dates you were looking at?
I believe it was January 26th to the 29th.
And during that time frame, was there a significant storm forecast for that time period?
Oh, yes.
And what was the forecast for?
Well, the forecast for the first couple of days was dry and very cold to bitterly cold. As we got closer to the 28th and 29th, we were looking at a storm coming in from the west and strengthening along the mid-Atlantic coastline, and we issued warnings, again, 2 to 3 days ahead of time to let our clients know that this was going to be a significant winter storm.
And specifically with the storm, what was the timing associated with that forecast as far as when would the storm begin?
We expected the storm, the snowfall, and the increase in wind to begin very late Friday evening, the 28th, with light to very light snow, and then to increase in intensity, especially later in the morning and through the late morning and midday of the 29th.
Now, from a scientific perspective, what is a blizzard?
A blizzard technically requires a great reduction in visibility. It doesn't even have to be snowing. Either falling or blowing snow, visibility a quarter mile or less, with winds of 35 miles an hour, either sustained or frequent gusts for 3 hours or more.
Now, did this particular storm meet that criteria?
The storm did, absolutely, for Boston and much of the greater Boston area, including in Canton at the Blue Hill Observatory. However, not every spot had all of those criteria during the entire time period that the snow was falling.
Now, how significant a storm actually occurred, not taking away from your forecast, but actually occurred during that time frame?
This was the biggest January storm in history, with 27 inches of snowfall. And it snowed heavily for several hours, visibility under a quarter of a mile. And the temperature was dropping during that time, and the winds were gusting frequently to 40 and 50 miles an hour in this area.
Now, that data that you looked at from that time frame of January 26th through the 29th of 2022, what types of data specifically did you look, or actually, we'll get to specifics in a moment. What data in general terms did you look at in your analysis?
3 locations, the Blue Hill Observatory, which is the oldest continuously operating weather observatory in North America, close by, Boston, which is the first order weather station at Logan Airport, and Norwood Airport, which is a mile away. And those were the 3 locations. I was considering the surface observations from those locations, also considered other types of observational data. I mentioned the radar data, so the National Oceanic and Atmospheric Administration maintains a NEXRAD NOAA database. And third was the National Operational Hydrologic Remote Sensing Center, which categorizes snowfall and snow depth. So those 3 different types of data at those 3 different locations.
Now, when you talk about the Blue Hills Observatory being the oldest in the country, how old is it?
It was established by Abbott Roch, who left his family home at 5 Commonwealth Avenue in Boston and built this really strange little structure at the top of Great Blue Hill on February 1st of 1885.
And do you know how far away from 34 Fairview Road that Blue Hills Observatory is?
Yes, I do. If you don't mind me consulting my note for a moment.
So what are you reading, Mr. Gilman?
I'm reading notes I took on measurements from Blue Hill to Fairview, and that's, may I answer the question? Your Honor?
Yes, you
I'm
may.
okay with Your Honor, I just wanted the record to know.
Yes, that's why I asked him what he's reading.
Thank you, Your Honor.
That would be 7 miles.
And the Norwood Airport, how far again is that, or how far away again is that between Norwood Airport and 34 Fairview Road?
1 mile.
Now, these measurements that you used in your analysis, are you familiar with how those measurements are taken or how they're done at each of those 3 locations?
Yes.
And can you explain to the jury sort of how those measurements are done or how those calculations or the data is collected?
Sure. Boston, again, is a first-order station. It's equipped with automated equipment. It's called ASOS, Automated Surface Observing System, and it takes measurements of temperature, visibility, wind, humidity at very frequent intervals throughout the 24-hour day. It also collects precipitation, which isn't easy if you think of Logan Airport being out in the harbor and trying to collect every raindrop in that environment. But they have a very sophisticated rain gauge system that actually does a fairly good job of collecting precipitation. Moving on to Norwood Airport, very similar. It's not as high a caliber a station as Boston is in terms of the frequency of observations or the complete set of data. Blue Hill Observatory is a special case indeed. It had been manned for most of the day for many years. The former observer is still alive and well in Hingham, Bob Skilling. For the last several years, 10, 15 years or so, it was an ASOS system that I just mentioned, but in recent years that was cut back So there are observers that are there, and they take observations when they're there, and they take automated observations otherwise and take a record of that. But it's not on the, for instance, the FAA network, Federal Aviation Administration. Weather data, of course, is extremely critical to aviation, and they have a network of weather data. The Blue Hill Observatory currently is not on that network.
Now, how the data is collected or calculated at each of those respective facilities, is that how it's standardly collected within the industry?
Yes.
And is it a routine both in your practice and in your meteorological industry as a whole, relying on that type of data and the way it's collected?
Yes, there are standards established. I'm a member of the American Meteorological Society, the Professional Society of Meteorologists, and there are standards that are established on taking weather measurements.
Now, may I approach, Your Honor?
Yes.
Mr. Gilman, Your Honor, may I remain here just a
Sure.
moment? Mr. Gilman, I'm handing you a series of, I believe it's about a 6-page document. You recognize that?
Yes.
Back a little bit more so the jurors can see the witness, please.
Do you recognize that, sir?
Yes, I do.
Well, what do you recognize that?
This is a local climatological data sheet for January 2022 for each day, and I believe there's, as I look through it, hourly reports of weather observations, especially for January 29th at Norwood Airport. And this is published by the U.S. Department of Commerce, NOAA, the National Environmental Satellite Data and Information Service.
And at least in part, is that the data that you were testifying about before as far as the data that you relied upon in your study here?
It's one element, that's right. And again, I put a lot of strength to this data because it is in such proximity to Canton, to the location we're concerned about.
Your Honor, the Commonwealth seeks to introduce and admit as the next exhibit.
No objection, Your Honor.
Okay. Exhibit 60.
Your Honor, with the court's permission, may I return what's now been marked as Exhibit 60 to the witness?
Yes.
Thank you.
So, Mr. Gilman, starting with snow accumulation, during the period that you were looking at, what is it that you found?
The snow began to accumulate during this winter storm. And by the way, I think I can use the term nor'easter, blizzard, bombogenesis, bomb cyclone, winter storm, all referring to the storm event of the 28th, mostly the 29th. The first snowfall began late in the evening on the 28th and continued into the 29th.
Just starting with that snapshot of the evening of the 28th, how much snow accumulated on the 28th before turning the page to the 29th?
Very little. Enough to track a cat, 0.2 of an inch.
Now, with reference to the 29th, were you able to determine from that data sort of the hourly snowfall as it came down?
Yes, as the hourly precipitation data, temperature, and other information was reported, I was able to analyze it each step of the way as the storm progressed.
And from your analysis, sir, could you describe to the jury, sort of going bit by bit, what was that hourly snowfall for the 29th?
As I said in the report, it's estimated that as it began, it was on the order of 0.3 of an inch an hour on the 29th until 1 o'clock, and it stayed in that light range. And anything under an inch an hour of accumulation is termed light snowfall. So that by 3 and 4 a.m. we were looking at 3, 4, 5/10 of an inch an hour. There started to be an increase more noticeable in the intensity by 5 a.m. with another inch, and then by 6 a.m. with another 1.2 inches.
If I could stop you there just for one moment, Mr. Gilman. So from the time period from when the storm began on the 28th to the time period of 6 a.m. on the 29th, how much in total snowfall had accumulated at that point?
I believe that was, do my arithmetic, 3.9 inches up to 6 a.m.
And I'm sorry, sir, if you could continue now going forward from 6 a.m. on the 29th.
Then we started getting into a more moderate snowfall, and again, that's an inch an hour more, so that by 7 o'clock was another inch and a half. By 8 o'clock, another inch, inch point one. And then by 9 and 10 o'clock, it was getting to be moderate to heavy snowfall based on radar returns, the next-rad radar information, based on the visibility reduction, based on the amount of precipitation that was melted in the rain gauges, based on other reports from cooperative observers. So that's on the order of an inch and a half an hour of intensity, and that continued through the middle of the day, rapidly accumulating on the ground, and it accumulated at even 2 inches an hour by the early afternoon, before it started to wind down in intensity, as these types of storms always do. By 7 or 8 o'clock in the evening, it was back down to light snowfall, ½ inch to 2/10 of an inch, and the snowfall accumulation had ended by 10 o'clock at night.
If I could take you back just a little bit to right before it turns from the moderate inch and a half per hour to about the lighter snow. About how much snow had accumulated at that point? Around 6 p.m. or so.
Around 6 p.m.?
Yes.
Well, again, I'm just going to do the arithmetic of subtracting the snowfall after 6 p.m., which was 1.3 inches from the total, which was 23.8. Do that arithmetic. 23.8 was the total snowfall, and 1.3, 22.5 inches.
So that's 22 and a half inches, just short of 22, excuse me, just short of 22 and a half inches by 6 p.m. Is that correct?
That's correct.
And what was the total snow accumulation from the storm in its entirety again?
23.8 inches.
Okay, so just short of 2 feet. Is that correct?
That's correct. The biggest snowstorm in January in our history.
Now, sir, have you prepared some visual aids to assist the jury with the snow accumulation?
Yes.
May I approach the witness again, Your Honor?
Yes.
Mr. Gilman, showing you 3 documents. Just ask you to look at those for a couple of finish.
Yes, I've seen these, yeah.
And what do you recognize each of those 3 to be?
The first one is a storm warning report that was sent to our clients in this area regarding the upcoming snowfall, winter storm. And we began sending this type of report, as I said, 3 days prior. This was one of the last ones that was sent as the storm was getting underway in this area. So this was sent by my colleague, my partner Bill Guile, at 8 o'clock that Friday evening. And it's a detail of when the snow is going to start, when the first inch will be on the ground, the total snowfall, the duration of the storm, and what's going to happen after the storm, which is also critical for our clients to know how to clean it up and what kind of post-storm conditions as far as temperature and other things to consider. So that's the heading of the form. Then we get into this detailed 6-hour time block series. And of course, that begins at 6 p.m. to midnight since this was issued at 8 p.m. And we talk about the weather conditions and how much, if any, snowfall.
I don't mean to interject, but just you recognize what's on that, and that is a forecast that you sent out, correct?
Yes. Our company sent out, my partner Bill Guile actually sent it.
And the last two sheets that you have before you, what are those?
These are images taken from one of those three sets I talked about, the data set from NOAA, the National Operational Hydrologic Remote Sensing Center, and it's a image of snow depth or snow on the ground at 2 times on January 29th. The first time is 1 a.m. and the second time is 7 a.m. And it's a map of Greater Boston down to the South Shore into northwestern Rhode Island.
Can I go, Sean?
Yes.
Almost introducing them as the next 3 exhibits.
No objection, Your Honor.
All right, thank you. Great.
And again, Your Honor, may I return those to the witness?
Yes.
Thank you.
Now, Mr. Gilman, what is the difference between a forecast versus a report of actual conditions or weather measurables?
As defined, a forecast is your best estimate based on science and data available of how the future is going to play out in terms of weather, the amount of snowfall, the temperature, the observed data. And I often make the distinction between soup and sandwich. Weather and forecast always seem to go together, but there actually is weather, and that's separate from what the forecast is, and there's always some small distinction. Lately, we've been getting pretty good at getting accurate weather forecasting done, but it is the actual weather that's measured. How much snow is on the ground, how much snow fell, what the wind speed was during any given period, temperature, those kind of elements that actually occurred.
And, Your Honor, with the court's permission, may I publish to the jury on the screen a copy of the forecasting document?
Okay.
Ms. Gilman, if you could. Thank you. And Mr. Gilman, what's up on the screen? Is that what you have before you as the forecasting document that's now been marked as an exhibit?
Yes.
Okay. And if you could, directing the jury's attention from left to right as far as the columns go, if you could walk the jury through sort of what we're looking at in this particular aid.
Sure. So below the heading, I think I defined the heading just before, we have these 6-hour time periods. So the columns are the day, in this case today being Friday in this forecast, the weather, the amount in inches, that would be of snowfall, the temperature, that's the air temperature, and air temperature is taken 5 feet above the ground in a natural surrounding. The road temperature, also in Fahrenheit, and that is the surface ground temperature, which is very important to our clients. And then we have wind, both sustained and gusts. Below that, we have special notes to amplify our message. A lot of times people don't read everything, so we try to highlight what's important or add something that wouldn't be in one of those columns.
And as far as the air temperature is concerned, as far as it being recorded, does that incorporate wind chill into that temperature, or is that something else?
Wind chill is a calculated amount or figure of heat transfer based on how human beings react to temperature. So this is the actual temperature that would be measured on a thermometer.
And thank you. And Ms. Gilman, if you could scroll down. And again, on the bottom portion of this aid, again, if you could walk the jury through what we're looking for and what we're looking at, and specifically, if you could draw their attention to the snow accumulation that's forecast in this.
Certainly. The same applies to the columns. Now we're into the tomorrow. So since this was issued at 8 p.m. on Friday, tomorrow is Saturday. And we're going through each 6-hour period and how much snowfall could be expected. You see it starts with 3 or 4 inches and then ramps up as we get later in the morning to as much as 6 to 10 inches of snow. And you can calculate what that hourly rate might be based on the 6-hour period. We give that type of range because it's scientifically accurate. People really want to know every minute, every hour, and that's just not something that modern science can do. So we give this period to be as accurate as possible while still being extremely precise. 7 to 9 inches during the afternoon period, and then it winds down to 2 to 3 inches toward midnight.
Thank you, sir. Ms. Gilman, you can take that down. Now, Mr. Gilman, the snow accumulation, how is that measured as far as the measurements that you get from each of these 3 sites? How is that measured at those sites?
At Blue Hill Observatory, there's often an observer, a trained observer, making measurements. The standard is to use what we call a snowboard. And if any of the members of the jury do weather observing or no weather observers, you might be familiar. It's just like a piece of plywood, something that doesn't radiate like pavement would or a house would. Just something that would allow the snowfall to accumulate in a natural way, and then that's cleaned off every 3 hours, and those amounts are added throughout the duration of the snowfall event. So that's the way the observers at the Blue Hill Observatory literally have been doing that since 1885. When you come to Logan Airport, you don't have an observer right there. There was back in before the 70s, 80s, around that time period, before ASOS came into play. There were people that were in the weather office that would go out and make those measurements. Now they contract with an observer, and I'm not sure of the location right now or during this event in 2022. I believe it may be in Winthrop, but it's very nearby to Logan Airport, and this is a contracted observer that makes these measurements. At Norwood, there is no snowfall measurement made right at that location.
Now, you've used a term a couple times as far as heavy snow. What is, scientifically, what do you mean by heavy snow?
Heavy snow, again, can be defined in 2 ways. Either by the reduction in visibility or by the accumulation rate. So it's an intensity of snowfall. And in terms of visibility, it would be less than 1/4 of a mile. So something like 3/8 of a mile. That's when you get into the heavy snowfall range. Intensity, in terms of the way it accumulates, might be more familiar to most of us since we don't know what that visibility might or might not be, but it's 1.5 inches an hour or more. It's not something that you want to be driving in, or very hazardous and big impact on a lot of our activity.
Now, what is the scientific definition of whiteout conditions?
I don't know if there's a scientific explanation, but it's a good term that is used quite a bit, and it would be heavy snowfall. Again, snowfall can reduce visibility to near zero, even below 3/8 of a mile. You may be getting 2 inches of accumulation, 3 inches per hour. When you have a very convective, energetic storm, like a thunder snow event, a lot of upward motion in the atmosphere, you could get 4, even 5 inches of snowfall per hour, and that certainly would be termed whiteout. I think it has a lot to do with the fact that we drive a lot these days, that people are familiar with limitations to being able to drive a car. And, you know, if you're driving along, the windshields are going, wipers are going at maximum speed, and you just can't make out anything on the horizon or the car in front of you, you say, it's whiteout conditions. You know, that's the way it's reported.
And did each of those, as far as heavy snow and whiteout conditions, occur in this storm?
Heavy snow definitely occurred in this storm. I've heard it referred to as whiteout conditions, and it's somewhat in the eye of the beholder, but I would say yes, whiteout conditions did occur.
Now, turning your attention, Mr. Gilman, now to the topic of visibility, can you describe to the jury what your understanding of that term is as it applies to what you do?
Well, visibility is just the reduction of how far you can see based on some weather element, as long as we're talking about weather. So haze can reduce visibility, fog, different types of precipitation, smoke can reduce visibility in the atmosphere. But in terms of snowfall, the heavier the intensity of the snowfall, the lower the visibility.
And so from a meteorological standpoint, how is that measured?
Well, it's measured in miles, or quarters of a mile, which is the standard here in the United States. And you sometimes see it in eighths of a mile, but generally with these automated systems, it would be 3/4 of a mile or half a mile, or as the snow intensity lightened up quite a bit, it may go up to 7 miles. I've seen snow falling at 10, even 11-mile visibility, which you'd hardly notice if you were out. That's not much of a reduction in visibility, but it can come all the way down to near zero.
And what was the lowest, if you know, the lowest recorded measurement as far as visibility as it pertained to this storm?
I would base that on the Norwood Airport because it was, especially in this immediate area, and they do a good job of measuring visibility, and that came down to 1/4 of a mile at the airport. It certainly may have been lower than that at times, but was on the order of 1/4 to perhaps as low as 3/8 of a mile or 1/8 of a mile between observations.
Now, sir, if I could turn your attention to the topic of temperature. How is temperature measured in your analysis as far as the data that you have?
Temperature is measured with a thermometer, and there are different types. We depend heavily on electronic thermometers now that measure the amount of heat in the air, and we get a reading, and we generally use that reading as the air temperature.
Now, what is the difference between air temperature and road temperature?
Again, air temperature, the standard is the temperature of the atmosphere 5 feet above the ground in a well-ventilated natural surroundings. Road temperature or ground temperature is actually at the surface, so it's out beyond the atmosphere, right at the surface of the ground.
And what kind of tools are used or utilized to measure road temperature?
There are basically two ways. One way would be to put some kind of sensing device, a probe, in the surface, just below the surface. And the other way would be to use infrared radiation. So you'd mount a sensor on a pole, and that infrared wavelength measurement would give you a road temperature or surface temperature.
Now, you mentioned earlier in your testimony that road temperature in particular is important to your clients. Why is that?
And I've heard this so many times from our clients. You know, you can forecast or expect an inch of snowfall or 3 inches of snowfall. If it's going to melt because the road temperature is 34 degrees or 35 degrees Fahrenheit, they don't really want to do anything. You know, they don't want to put a lot of chemical down. They don't want to hire private contractors with plows. Whereas if it's going to accumulate, especially on the road surface, they need to be prepared. And there's so much demand now on having black pavement during winter storm events. There's so many automobiles on the roadways in this area. that each of these municipalities is constantly under demand to make sure they do the best job they can. And in order to do that, they need to know what the road temperature is going to be or the ground temperature is going to be in order to best have snow and ice operations to meet those demands.
Now, is there a difference, or what is the difference in the changes to air temperature as opposed to the change in road temperature?
They're different substances, so they have a different pattern of temperature change. Air temperature changes much more quickly. And of course, when we're talking about temperature, we're talking about energy, the way the molecules in the atmosphere are moving. The faster they're moving, the higher the temperature, the more energy. So depending on what is causing that change in temperature, the atmosphere is going to react more slowly. The ground will react more slowly to the change. The atmosphere will react pretty quickly, or much faster.
Now, in your analysis here, what time frame again were you using, or were you measuring the temperature across?
I
Let me ask you
looked at
this
the
way.
enti- yeah,
You
go ahead.
started on January 26th through the 29th, correct?
Correct.
Okay. And why is it specifically with temperature that you started on the 26th as opposed to anything else?
I was asked to start at the 26th, and I said that's a good way to go because it establishes a period of seasonal freezing ground. It typically happens in this climate in the midwinter that our ground freezes. So if you look a few days before, you get a good sense if that was the case. I mean, there have been winters, there have been months of January in recent years that we've reached 60, even 70 degrees, and nothing is going to be frozen during that time. This was not the case in late January of 2022. It was an unusually cold period, and it was important to record that.
Now, can you describe to the jury or lay out for the jury the temperature readings throughout that period of time that you analyzed?
Yes. I'll start with the 26th and just go without going through more than just a day high and low. A high of 28, a low of 12. On the 27th, the high was 27 and the low was just 9 degrees Fahrenheit. On the 28th, Friday, the high temperature reached 36 and the low was 22. And then on Saturday, the 29th, the high temperature was 29 and the low was down to 15.
Now, sir, if I could ask you specifically within that time period, a specific time period of approximately 1:30 a.m. on the 29th through 5 a.m. on the 29th, what does the data demonstrate with respect to the air temperature during that period?
From 1:30 to 5:30
Yes, please.
on the 29th? All right, I'll consult this data from Norwood Airport if that's the way we should look at this. I would suggest to do that. And at 1:30, the temperature was 31. By 5:53 in the morning, it was down to 24 degrees.
During that time period, before that, is the temperature relatively stagnant during that time period of 1:30 to 5 a.m.?
Before that time?
During that time.
Oh, during the early part of the time, and again, this is right at Norwood Airport. It might have been a little bit colder in Canton. It certainly was colder at the Blue Hill Observatory, but I don't have a lot of that, so I'm using this.
Sure.
So based on this, it was pretty steady through around 2 in the morning. And then because of the nature of this type of storm, it's deepening rapidly. It's low pressure offshore. So the wind tends to back from the northeast to the north-northeast to the north. And that backing wind starts to draw our air rather than from the Gulf of Maine, the Atlantic Ocean, the harbor, more from northern New England and Quebec. So that's a tendency of all of these winter storms to tend to get colder as the storm intensifies. And that's what we see starting to happen as you get toward 2:30 in the morning, and especially 4:30, it's down to 28, 26, and then down to 24 degrees just before 6 in the morning.
And that temperature sort of fluctuation or lack thereof, is that consistent with what you would expect in this type of storm?
It's exactly what I would expect, and this is a classic winter nor'easter, and that temperature drop is part of that.
And lastly, sir, if I could just take you back to the road temperature you were talking about before. How would you describe the temperature readings generally from the 26th through the 29th as far as what type of temperatures were recorded during that time frame that you just testified about?
As I said, it's the coldest time of the year anyway, in late January, here in the Boston area around Canton, midwinter. And this particular year, 2022, it was colder than normal. So road temperatures were dropping much of the time. They may have come up a little bit during the course of the day, thanks to sunshine during the 26th and 27th. A little moderation in the temperature on the 28th, but for the most part, there was a frost in the ground, the soil was frozen, and the temperature was unusually cold at the middle of winter.
And what impact would that have on the hardness of the ground over that time period?
Well, again, the ground was frozen, the soil was frozen, and the surface of the ground was frozen. And it would have made the ground impenetrable, that hard, you know, as hard as too difficult. You wouldn't be able to dig in the ground.
Thank you very much, sir. I have nothing further on.
All right, Mr. Lessie?
May I approach, Your Honor?
Yes.
Thank you.
Show Mr. Lally, please.
With regard to Mr. Lally and myself, we have agreed I'd like to address the court with a stipulation, and with regard to the document we stipulated into evidence, to execute measures.
Yes, Your Honor, may we approach this very briefly?
Okay.
Thank you, Your Honor.
Thank you.
May I, Your Honor?
Yes.
Good afternoon, Mr. Gilman, and congratulations on your career up to this point.
Thank you. Good
I had
afternoon, almost.
Pardon me?
Good afternoon, almost.
I have some questions for you, if I could, please. You covered a bunch of topics on your direct examination, and I wanted to confirm some of them. As a meteorologist, you indicated that you look at a variety of areas under the larger umbrella of weather, correct?
Correct.
And one of those areas is snow accumulation.
Correct.
Another area is visibility, correct?
Correct.
Do you have a general understanding about what this case is about? Let me ask it this way. As regards weather conditions, are you familiar with an address of 34 Fairview Road in Canton, New York?
Yes.
And have you ever been to 34 Fairview, Canton, New York?
Not New York. This is
I'm
we're in
sorry,
Massachusetts.
I'm sorry,
Okay.
Massachusetts, sir?
Yes. I've been in many parts of Canton. I don't believe I've ever been to 34 Fairview.
Are you generally familiar with that area?
Yes.
And you've mentioned the Norwood Airport on your direct testimony, correct?
Yes.
And is the general area of Fairview, is that in close proximity to the Norwood Airport?
I mentioned it's a mile away.
Right, so it's fairly close, right?
A mile.
Right, so you would expect that the readings you talked about on your direct examination would have a direct bearing and relevance to the 34 Fairview Road in Canton, is that correct?
Yes. Relevance, yes.
Yes. So what I would like to do is to draw your attention to the exhibit that was just marked, if Your Honor. We have that. May I approach, please?
Yes.
Thank you. Mr. Gilman, this is Exhibit 64. If I could hand that to you, please.
Thank you.
And you can keep that in front of you. If we could publish. Excuse me, Your Honor, may I publish?
Yes.
Thank you. If you can enlarge, just, no, not the whole thing, just the chart up above, and make that as large as you could for the jury, please. That is very good, thank you. You see where we are, and Mr. Goodman, you can either look on the screen or look on the document, whichever is best for you.
Thank you.
You're welcome. So let's start with the top, which is estimated hourly snowfall ending at. This is for January 29th, 2022, correct?
Yes.
And what does not appear on this chart, but I want to make sure I can get this as accurate as possible, would it be appropriate to, before 1 a.m., to add a 0.2 for what you mentioned on direct for midnight? You mentioned there was a little bit starting, and there was a 0.2. Is that correct? Did I hear that correct?
If you want to get the total for the snowfall event, yes.
Okay, so we'll just have, if you will, an imaginary 0.2 up at the top. And what I'm going to do, sir, is I'm going to go through the hourly snowfall, because there are times that you have on your chart that are relevant in this matter. So let's start with, and just do it chronologically by time. And what I'm going to ask you to do is to do a little bit of math as we go through. If you need a calculator, I think it's going to be fairly straightforward math for someone with your skills, but take your time when we get through it. So we start at midnight, and you mentioned the concept of visibility on your direct examination, correct?
Yes.
And I believe you said on your direct examination that at midnight there was, quote, very little snow precipitation. Is that correct?
I believe I said there was very little snow on the ground.
Very little snow on the ground, and I think you used the phrase track a cat.
Enough to track a cat, exactly.
Right. And so enough to track a cat, but a fairly small amount, correct?
I don't know how to define it any better than enough to track a cat.
Very good, sir. I'll go with track a cat.
That's as small as amount as you can get. And again, that would be on a natural surface, not necessarily on pavement.
Right. And what would the variation be, if at all, on pavement?
Oh, a lot of factors would come into play. Most importantly, since this was a forecasted storm event, the town may have pre-treated the road. That lowers the freezing point of the precipitation, so it would, even if it was 25 degrees, it might be melting on the road.
So in terms of the factor you just talked about, for example, pre-treatment, that could cause the accumulation, the numbers here to be lower than what we're seeing on the chart, correct?
Definitely, correct.
But there's not a scenario where it could be higher, is it, at this point?
Well, there are places, especially with this kind of wind and dry, fluffy snow, that you would have drifting.
Right, but with just 0.2 inches on the ground, would you expect drifting?
No,
Okay.
absolutely not.
Right,
Not unless I was a very small animal.
I was going to say, tracking a cat wouldn't
No.
seem to work very well if you've only
No.
got a drifting with 0.2.
I thought you were asking about the larger numbers.
No, sir, good point. What I'd like to do is to just concentrate on the beginning here and midnight and 1 a.m., and then we'll progress down through, okay? I
Okay.
want to snapshot it, if you will, starting at the very beginning. So we then move to 1 a.m., which is 0.3 inches, correct?
Correct.
Now, if you add, and it seems like to be most accurate, to each number here, we would add a 0.2 to get the total, correct?
Correct.
So if we go to 1 a.m. on January 29, 2022, we've only got 0.5 inches of snow per this chart, correct?
Total so far, yes.
And that could, on the road, that could be less because of municipal pre-treatment. If they pre-treated for the storm, they could have put some chemicals down that would have caused a melt and therefore less. That's a possibility.
That's one factor. Another factor would just be the road may be warmer for a number of reasons.
So that could be another reason why it might be less, another factor.
Absolutely.
Okay, so now let's go to, I want to go between 1 and 2 a.m. Let's assume a time of 1:45 a.m. on January 29, 2022. Is it correct that the accumulation would be less than 0.8 inches at that point, according to your chart?
By 2 a.m., it would be less than 0.8, yes.
Therefore, correct.
Therefore, by 1:45, it would be less than 0.8, yes.
Right, so-
Or equal to, if yeah.
I'm sorry, I didn't mean to interrupt you,
Less
sir.
than or equal to.
Right, so you used 2 a.m., right, which would mean that it was 0.8, correct?
Correct.
And then if you work back 15 minutes, at 1:45 a.m., it would be less than 0.8, correct?
If it was still snowing in those 15 minutes.
Right.
Yes.
So, but I just want to focus on the number.
Yeah.
At 1:45 a.m., it's less than 0.8 inches, correct?
It's less than 0.8 inches.
Yes,
Okay.
right, alrighty. So, and that is, to state it another way, is it correct to say it's just 0.8 of an inch? Is that correct?
0.8 is 0.8 of an inch. Yes.
Right, another way to say it. So, in terms of the time now, and this may get a little more complicated, sir, but if you take just the time between 1 a.m. and 1 a.m. and 2 a.m., so you've got 0.8. You would have under at 1:45, is it correct you would have only 0.35 inches accumulated of the 0.8? You follow my math, sir?
I'm not sure what I follow in that sentence. Did you ask me how much snow fell between 1 a.m. and 2 a.m.?
That's another way of asking the
Okay,
question.
between 1 a.m. and 2 a.m., 0.3 of an inch is the estimated snowfall.
Right, very well. And so what I'd like to do now is to move down the chart to 3 a.m. How much snow has fallen or accumulated between 12 a.m. and 3 a.m.?
It would be 1 inch.
Right, and is an inch, and you're in the measurement business, about the size of a thumbnail?
Yeah, I actually use the knuckle on my thumb to the end of my thumb as an inch.
Right, so from the knuckle of one's thumb to the end of the thumb is 1 inch. Right. And under your terminology on direct, you had used the term very little. Would you consider from the knuckle to the top of the thumb very little snow?
It definitely would require a comparison. 1 inch of snow has caused tremendous problems for people.
Right.
So I would not call it, just by the fact of 1 inch of snowfall, I would never say it's very little.
No, so I'm sorry, maybe my question wasn't clear. I'm not talking about effects of 1 inch. I'm just talking a measurement of 1 inch on a measurement scale. Would you still consider that your phrase, track a cat, or would you be out of the track a cat?
We'd be out
group?
of the track a
All
cat
right,
stage.
got it. So, but again, the 1 inch being from the knuckle to the top of the thumb.
Yes.
Let's now go all the way down to about another time is 3:30 a.m., which we're going to focus on now, 3:30 a.m. How much snow had accumulated by 3:30 a.m.?
Well, we're going to have that inch we just talked about at length, and we're going to add the 0.2 from the previous day, the last few hours of the 28th, so we have 1.2. And now we're going to add another half an inch by 4 a.m., so somewhere less than 1.7 inches, less than or equal to.
Wouldn't the number at 3:30 be 0.85 inches?
You're including the snowfall from the previous day, the 0.2 of an inch?
Yes.
No.
What would it be?
As I said, there's 1.2 inches up to 3 a.m., and then we're adding some amount before 4 a.m. Unknown how that was distributed within that hour, but something like 1.7 equal or less than total.
How about the accumulation between 1 a.m. and 3 a.m.? How much accumulation for that time period?
Between 1 a.m. and 3 a.m., so we have 0.3 of an inch up to 2, and another 0.4 of an inch, to a total of 0.7.
So between 1 and 3 a.m., there's only an accumulation of 0.7, correct?
Correct.
Inches.
Correct.
You had spoken a lot on your direct testimony about the magnitude of the storm, a variety of other measurements. But what I wanted to draw really a line at 6 a.m., which you said was an accumulation of 3.9. What I want to do is to now move on to from 7 a.m. on January 29th until noontime. And you can check my math, sir, but I get 12.5 inches total as of noon on January 29th.
I can do the arithmetic if it sounds about right. 6, 8.6 inches fell up until noon, starting at 6 in that time period, which is about the amount we forecast. And did you ask about the total going back to the night before, or
Yeah, the total starting at midnight,
starting at midnight?
right, going until noon, so it's a 12-hour period of the same day, January 29th.
My quick calculation is 12.3 inches.
Right, and then you'd add the .2 from midnight?
Previous to midnight, yes.
Right, so 12.3 is what shows with all those numbers, but then you have to add the 0.2 from midnight, which would get you to 12.5, correct?
Exactly, yep.
Good. So just to summarize the first column there, all the way down from 1 a.m. to 12 p.m., at 6 a.m. we've got 3.9 inches, and then moving down to 12 p.m. we're at 12.5 inches, correct?
I believe so.
Sir, tell me when you're
Yes, yes.
So we're in alignment with those two numbers, 3.9 inches as of 6 a.m., 12.5 inches as of 12 p.m. on January 29th, correct?
Yes. Yeah, I'm sorry if I wasn't sure if you wanted me to do all the arithmetic again, but I did do that, and yes.
Okay, good. Thank you. I appreciate you doing that. You talked about the concept of visibility on your direct examination. In terms of visibility, did I hear you correctly that there's a correlation between the amount of snow coming down and visibility?
The intensity of the snowfall, so the amount over time and visibility, right?
Right. So the intensity or amount over time. How would you describe visibility from 12 midnight or 12 a.m. on January 29th until 1 a.m., that 1 hour period? How would you describe visibility?
I really don't know exactly. I can look at the report from Norwood Airport. They measure the visibility.
Could you do that, sir? Would that be easy enough for you to do?
Do you need a light, Mr. Gilman? Do you need lights on?
If we're going to do more than one, I would, but let's see if I can. Thank you, Your Honor. And we were asked about 1 a.m., is that?
Yes, visibility at 1 a.m.
Okay. Visibility reported at 1 a.m. was 1.2 miles in light snow.
And what does that mean, a visibility of 1.2 miles?
1.25 miles, 1.25 miles. That means that anything that was more than 1.25 miles away from the observer would be hidden by the snowfall. You wouldn't be able to see it.
And what does it mean if the visibility was less than 1.25 miles?
And as the visibility lowers, your ability to see objects in the distance is reduced.
So assume, sir, that somebody is 30 feet away from an object they want to see, and the visibility is 1.25 miles. Would they be able to see that object based upon your experience with visibility and your career in that area?
All other things being equal, yes.
Right. So would it be fair to say visibility would be good from 30 feet if it's a 1.25 mile and beyond?
Can you answer that, Mr. Gilman?
Can I further explain to the jury about visibility? Thank you. A term like good for visibility would generally apply more toward 8 miles, 10 miles is good visibility. So it's hard to say that anything under 3 miles. For instance, we go from calling visibility reduction in haze to fog. Once it's really the same atmospheric phenomenon, but once you get below 3 miles, we call it fog or dense fog. So anything below that, when you reduce visibility by fog, haze, snow below 3 miles, it's hard to call it good visibility.
But if something is at 1.25 miles, there's visibility, correct?
Of 1.25 miles, yes.
There is
And again, if I could explain for the jury, a lot of this is developed for aviation.
Right.
And if you're a pilot or you think about what a pilot needs to go through, that's where these terms come from.
I understand, sir, but you are in the weather forecasting business, correct?
I sure am, yes.
And you, and weathercasters, we all here on TV talk about visibility on their forecast, correct?
Correct.
And they're not talking just to pilots, right? They're talking to people who are going to drive, people who are going to walk, is that correct?
And it is a challenge to communicate that, yes.
But sir, my question is, when someone, a weathercaster, weather person is talking about visibility, the main target audience are for people who are going to be driving or walking, correct? There's not pilots that they're giving.
Well, I don't know, but I would never expect, and I do broadcast meteorology, a broadcast meteorologist to say visibility was good if it was less than 1.5 miles.
Yeah, sir, I appreciate that, but my question's not, I've left whether it's good or not. I'm talking about the purpose of weathercasters speaking about visibility.
Yes.
You had indicated in your earlier answer you had tethered it to pilots, but there's also an application of the visibility concept for the rest of us in the world who drive and walk, correct?
Yes,
Isn't it useful for that?
Absolutely. I'm trying to answer your question about whether the visibility was good.
Right, but but I'm not asking that question anymore. My question is just,
I only know what you asked me.
All right. I'll try it a different way. Visibility is a concept that is used by weathercasters to assist people who are going to be walking or driving. Is that correct, sir?
Yes.
Thank you. So now let's go on to the concept of temperature. You mentioned the concept of wind chill on your direct examination. You recall that, sir?
I was asked about it, yes.
Yes. Does wind chill have a relationship to temperature, and if so, what is it?
It does have a relationship to temperature. It's a complex function that was developed by the U.S. Air Force in the 50s to help produce cold weather gear. And it was determined that wind had a major impact on our military in terms of what type of gear they needed, in addition to how low the temperature was. So it's a measurement of temperature to begin with, and then there's a complex function applied based on the wind speed to come up with how that air temperature, how that air is going to impact the human body.
So is it fair to say that if you have a temperature, and what I wanted to do is to go to the temperatures that you gave on your direct examination, is it accurate to state that, for example, on January 29th, I believe I heard you say there was a high of 29 and a low of 15. Is that correct, sir?
Yes, that was my report based on all those 3 locations, yes.
And you had also testified about wind speed and wind gusts as well. And can you state, if you have it in your notes?
I do, yes. It was
wind
in the
speed?
report, yep.
Yep. And what was the wind speed?
The-
Average and then high gusts.
Sure. 23 miles an hour with frequent gusts of 47 miles an hour.
So what does your number 23, how does that affect temperatures of 29 and 15?
It makes that air feel much colder. So that air, that 20-degree air, did you say 20 and
29, sir, and 15 were the numbers you had given?
that range for that day, sure.
Yeah.
So it makes that air temperature feel colder, and it allows that air to take heat out of your body more efficiently and more rapidly. So it feels much colder, and we can calculate roughly how it would feel if there was no wind at all.
And sir, thank you. You've gotten right to my next point, and I only have a few more questions left for you. So if you have the highest temperature on the 29th of 29, January 29, 2022, do you know what the wind chill factor would do in terms of a calculation number to bring that 29 number down? Do you know what that number would result in applying the most conservative wind speed of 23?
I wasn't asked to calculate that, no?
Would it be less than 0? Just an estimate,
Based on the 29 temperature?
based on the 29.
No,
Would it
I
be
don't
in-
believe so.
Would it be in the teens?
Yes.
So the 29 would be in the teens, and then for the low of 15, approximately what number might that get down to?
Again, depending on the wind, if you looked at 5 miles an hour, again, it wasn't that wind all day, and that 15 degree might not have been corresponding to any wind at all.
Just using your average that you used on direct of 23.
The average wind, again, made it feel much colder, bitterly cold, extremely cold when you were out in the highest wind at the lowest temperature. So it may have felt like 0 to even 10 below 0 at the lowest temperature and the highest wind gusts.
So if I got that correct, so 15 was the lowest temperature you gave in direct on January 29th, and you state that it would be, with the wind chill using about an average of 23, would be 0 or maybe minus 10? Is that the number correct?
Again, I'm just guessing. I didn't do the calculation. I wasn't asked to do the
Fair enough.
calculation. But based on my experience of reporting in this area for 45 years, I basically get the idea of what it's like when the temperature's that low and the wind is that high. Yeah.
Right, and if we could please have the chart published back up, please. You can keep the lights on, you just make it larger. I want to make sure Mr. Gilman has some facile with his notes. Okay, so is it correct to say that if the total accumulation for the storm was 23.8 inches, that the vast majority of that accumulation came well after 6 a.m.?
Yes.
And as of 6 a.m., we've only got 3.9 inches compared to what the storm ended up at about 23.8. And then, importantly, from midnight on January 29th until 3 a.m., we've got just 1.2 inches, correct?
Exactly.
May I have a moment, Your Honor?
Yes.
Thank you. Please bear with me a moment, Mr. Gilman. Thank you for answering my questions, Mr. Gilman.
You're welcome.
Anything else, Mr. Lally? Okay.
Mr. Gilman, you were asked about the snowfall between 12 a.m. and 1 a.m. How much snow again was there during that time frame?
During that time frame, about 3/10 of an inch.
Okay. And during that time frame was probably the least amount of snow that was on the ground during the course of the storm, correct?
During that hour or two previous, there was really In fact, I have this chart I showed, the graph, the map. It just showed a trace, a zero. There was less than an inch on the ground. And we measure snow on the ground in whole numbers, so it would either be 1 inch or 0.
And so that would be during what you've characterized as the track-a-cat stage, correct?
Yes.
And so it's during that track-a-cat stage that there's the least amount of snow between the frozen ground and anything that may come down on top of it, correct?
Yes.
Now, as quickly as it applies to visibility, when you were asked about visibility in 30 feet, you said all other things being equal. What are some of the things that would make it unequal?
A car in front of you, a building in front of you, a person, anything other than weather, and there are other types of weather that can lower the visibility besides snowfall, including fog.
So darkness, as far as nightfall versus daytime, that would have a negative impact on your visibility?
Objection, Your Honor.
Sustained.
What about lighting? How would
Lighting?
lighting impact the visibility of an object?
I really can't say that lighting, obviously, you need some light to see anything. That's really all I could say.
And lastly, sir, as far as wind chill is concerned, again, could you explain to the jury exactly what is wind chill? What is it measuring?
Again, it was developed for the military in the 50s to help design. It was actually done here at the Natick Labs here in Massachusetts to help design cold weather gear, because prior to that time, during World War II, the Korean War, unfortunately, especially Air Force aviators were suffering. They had clothing that might have been adequate for the temperature, but because of the wind, they suffered frostbite and other ill effects. And so research was done, and the result of that was a wind chill temperature, the way it would feel to the human body based on the wind on a certain temperature.
And so the wind chill is measuring the impact of how a person experiences the air temperature, correct?
Exactly.
I have nothing further. Thank you, sir.
Anything, Mr. Lassie?
No further questions, Your Honor.
All right, Mr. Gilman, you are all set, sir. Thank you.
You're welcome. Thank you.